Hello everybody, I hope you are having a great Monday and good start to the new week. Today we are going to begin the geometry unit. To begin the geometry unit, we are going to make flashcards for geometry formulas that we can reference, we can use to study with, and are just a handout to have that we could use to help us with homework and quizzes and future tests. So you need 7 note cards that you should have gotten passed out to you. If you have not gotten those, please make sure you go get those right now. On one side of the note card, we are going to write the shape and draw a picture of it. On the other side, we are going to write the formula for that shape. I will be giving you the formulas, but if you also want to define those in another area, they can be found on the back page of your textbook. The 7 formulas we are going to look at are, as you can see right now, and again, we will be going through those together. All right, so let's get started. And remember, you can pause this video at any time to make sure you are keeping up with making your note cards. So the first formula we're going to look at is area of a circle. So I'm going to write on the front, area, circle, draw a picture, and then on the back side I'm going to write the formula, and the formula for that is pi r squared. And if you can't quite remember what the r stands for in that formula, write yourself a note on that note card. R again stands for radius. All right, our next formula is circumference of a circle. So now circumference is different than area in that circumference is the distance around the circle. So if I want to make the front part of my note card, I would maybe write circumference of a circle. And draw my circle. Maybe what I'll do is I'll go in red and outline that to remind myself that it's the perimeter or area outside around the circle. And the formula for circumference of a circle, there actually is 2. So the first one we could look at is pi times diameter, or the other one could be 2 pi r, And the reason 2 pi r and pi times diameter works is because why? Hopefully you thought that correctly, because diameter is across the entire circle from one end to the next, and radius is halfway. So if I have 2 radiuses, that will make up the diameter. All right, for our third formula, area of a triangle. So I'm going to write area, triangle, and then I will draw my triangle in. The formula for area of a triangle is 1/2 base times height, or I could say base times height divided by 2. Those mean the exact same thing. Area of a trapezoid is next, and we don't talk about trapezoids as frequently as most other shapes until we get to the geometry unit. So I'm going to write in area, trapezoid, and a trapezoid looks like a base up top and a base down below, and the base on the bottom is typically wider than the base on top, unless of course we were to flip that around. And the formula for area of a trapezoid is 1/2 times the height times the quantity base 1, so b sub 1, plus base 2, b sub 2. b sub 2 there. Now, where the bases come from is base 1 would be the smaller base up top. Base 2, typically we call that the bottom one, slightly larger one. And then the height comes in here, where if I draw this in, this line straight down, this is the height right here. So this would be h for height. So I use 1/2 for the formula, 1/2 times my height times the quantity base 1 plus base 2. All right, the area of a parallelogram comes next. So I'll write on the front of my note card, area of a parallelogram. And a parallelogram, similar to a trapezoid, I have my 2 bases, but it's a little bit at an angle, right? So it's a little bit tilted, as opposed to with trapezoid, both sides kind of angle out, where parallelogram, again, both sides kind of, slant towards the same way. And the formula for area of a parallelogram is base times height. So just like that of a rectangle, of a square, base times height. So our base comes from one of the sides, either the top or bottom. They are the same length in a parallelogram. So those would be my bases. And my height drops straight down from one of my corners straight down to the side, where I would be able to form a 90-degree angle. And again, I could get the base from either side like that. So base times height for area of a parallelogram. Pythagorean theorem is a theorem that we will use quite often within the geometry unit. So Pythagorean theorem goes with a triangle, and specifically a 90-degree triangle. So I could form 90 degrees there in the corner. And Pythagorean theorem, I'm going to go ahead, if I won't be able to fit that on the front, the whole word, so I'll shorten it. So Pythagorean theorem, and Pythagorean theorem is the formula a squared plus b squared equals c squared. So where does a, b, and c come in? Well, a and b are what's called the legs of the triangle, so the two sides that are not directly across from the 90 degrees. So I could have side A and side B right there, and again, those really could alternate and those could flip-flop because they're both considered legs of a triangle. And C is called the hypotenuse, which is directly across from the 90-degree angle, also known as the longest side. And we have our last formula called the distance formula. So I will write distance formula there. And the distance formula goes with two ordered pairs that are graphed on a coordinate plane. So for example, if I had a coordinate plane, this will be my little sketch, and I had one point right there, another point right there. What our job would be is to find the distance that goes between those 2 points. So essentially, that purple line right there, or dots that I've made, and that will be a straight line. And how I find that is I take the square root of x sub 2, so the second x coordinate I have, minus x sub 1, the first x coordinate, the quantity squared, plus y sub 2, my second y coordinate, minus y sub 1, the quantity squared. And what do I mean when I say my second x coordinate, my second y coordinate, my first x coordinate, my first y coordinate? Well, you are given those from your ordered pairs. So if I had, two sets of ordered pairs like x comma y and another set x comma y, they're different, as you can see with the blue and the red there, that this x would be maybe like my x sub 1, y sub 1, where my second pair coordinate would be x sub 2, y sub 2. So I could just label those coordinates, and then when I know them, and I should know them because they're the points that I could find on the coordinate plane, or I probably was given, I could then plug them into the formula right there. Once you finish your note cards, your homework will be to go on to IXL on your iPad and complete levels 7.8A.4 and 7.8A.5 and receive a SMART score of 80 or higher on both. So you can see your SMART score down in the right-hand corner when you're completing IXL. And then remember, when you're taking IXL, 7.8A.4 there is circumference of a circle, so that is, pi times diameter, or 2 pi r. And then 7.8A.5 is what you're really going to look at tomorrow in algebra, and that is area of a circle, so that's pi r squared, that formula. So I would like you to go on to IXL and look at those and receive a SMART score of 80 or higher, and then when you're finished with that, you can work on your algebra homework that you received from class today and continue with that, or if there's anything you need to fix on your quiz from last week, you can certainly work on that. I would like your note cards to be completed, as well as a SMART score of 80 or higher on both IXLs by Wednesday when I see you, October 5th, at the beginning of class. And if you have questions on any of this, feel free to please send me an email or stop in my classroom tomorrow when I return. Have a great day, and I hope all goes well in class. Bye-bye.